In this video, we'll take a look at some of the more advanced options for structure searching in Lead Discovery ChemCharts. The substructure search options are located at the lower left of the structure search dialog. Here you can choose one of any, all, or count. You can also elect whether to match stereochemistry. Let's take a look and see what effect these options have on substructure searches. First, we'll enter a simple pyrimidine query. We'll select count in the substructure options and click OK to start the search. After the search is complete, notice that the calculated column produced by the search contains the number of times the query substructure was found in each molecule. In the item that represents the substructure search, the filtering controls are displayed as a set of checkboxes, allowing filtering of the data table by the number of matches. The effects of the any and all options can be observed if we enter a disconnected substructure query. Here I will draw a dichlorophenol-like substructure and a piperidine-like substructure. In this case I will choose the any option. After this I will create a second substructure search with the same query substructures, but in that case I will select the all option. If I uncheck the exclude checkbox for the search item with the any option, you can see the resultant molecules contain either the dichlorophenol or piperidine substructure. If I do the same for the search item with the all option, you can see that the resultant molecules must contain both the dichlorophenol and the piperidine substructure. When performing similarity searches, each molecule in the query is described by a fingerprint. The similarity of each of the molecules to the query is calculated by comparing the fingerprints using a metric. Here we have already drawn the query structure and we have selected similarity from the search type drop-down. The Morgan and topological fingerprints are good for finding molecules that have areas of high similarity to the query but may not necessarily look like a very close analogue. This makes them good at ranking diverse structures by similarity. Conversely, the atom pair fingerprint is very good at finding very close analogues to the query structure. The last fingerprint is the max fingerprint, which describes molecules by the presence or absence of a set of 166 substructures commonly found in drug-like molecules. At present, there is only one metric to choose from, which is the Tanimoto coefficient. Like most similarity metrics, it gives you a value between 0 and 1. As always, the details of the similarity search are stored in the search item representing that search. Instead of drawing the query molecule for a structure search, users can enter a SMILES or SMARTS pattern. To do this, click the SMILES SMARTS tab at the top of the structure search dialog and enter the SMILES or SMARTS into the text box. Note that disconnected substructure queries are supported here, just like the sketcher. If you have a large number of structure searches, you can maximize the number of them that are visible by setting the image size of the queries in the search items. To do this, you can cycle through the small, medium and large image sizes by clicking the icon at the top left of each structure search item. You can also set the image size by opening the Properties dialog, clicking on the Visualization tab and selecting the image size using the radio buttons. It is also possible to configure whether or not you want a tooltip to appear for the query images in the search items when you hover over them. Thanks for watching. Be sure to check out the other videos about the chemistry visual in Lead Discovery ChemCharts.